Today's lesson is on solving trigonometry equations. So our learning objective for today is I can solve all types of trigonometric equations by applying inverse properties to solve for the angles. Okay, so all the answers are angle answers because I am solving trig problems. Okay, so let's start out with, after I solve, I always have to make sure my solution is valid. So let's just do a quick, for checking solutions review. Is x equals pi over 8 a solution to 4 cosine squared 2x minus 2 equals 0? Okay, so I'm going to substitute in pi over 8 for x. So substituting in, I get 4 times the cosine squared 2 times pi over 8. And I'm going to put this like this. Minus 2 equals 0. So I'm going to multiply out 2 pi over 8 and simplify. So that's pi over 4. So 4 cosine squared pi over 4 minus 2 equals 0. For my unit circle, I know that the cosine of pi over 4 is the square root of 2 over 2. So this is 4 times the square root of 2 divided by 2 quantity squared, because cosine squared minus 2 equals 0. So this is 4 times the square root of 2, quantity squared is 2, and 2 squared is 4. Minus 2 equals 0. So 4 divided by 4 is 1. So I get 2 minus 2 equals 0. So I get 0 equals 0. So that checks out. So I verified that. So yes, x equals pi over 8 is the solution for this equation. All right, so solve for 0 to 360 degrees. Solve for the angle theta between 0 and 360 degrees. So I'm trying to solve for the variable, and the variable is always the angle. Since I is saying between 0 and 360, I know my mode on my calculator is going to be in degrees. Or my answers will be in degrees. Mode is degree, or answers is in degrees. Okay, so the first thing I'm going to do is I'm going to subtract a half from both sides. So I get sine of theta equals 1 minus a half is a half. So I am to understand that when I'm solving for angles, I have two possible answers because each trig function is positive in 2 quadrants and negative in 2 quadrants. So this one, I'm looking for the positive quadrants for sine because the half is positive. I know sine is y. So the 2 quadrants where sine is positive, so the y value is positive in the first quadrant and the second quadrant. So here's my reference angle. And then the 2 angles I want to name are in the positive rotation. So I want to name them this way. Okay, so I know using my unit circle. So if I'm talking about from 60, 45, and 30, so I should have this memorized. So 1, 2, 3, 1, 2, 3, all over a half, And then I'm going to take the square roots of the 2's and the 3's, because the square root of 1 is 1. So the y value, where I am a half, is at 30 degrees. So my alpha, my reference angle, is 30 degrees. So this is 30 degrees, and this is 30 degrees. So the two angles I'm talking about are at 30 degrees, and then 180 minus 30 is 150 degrees. So my reference angles, my two reference angles are 30 degrees and 150 degrees. Okay. So big picture, I want to be in terms of sine, cosine, and tangent. And I need to know that my answer, I am positive in 2 quadrants and negative in 2 quadrants. All right, so number 3. Cosine squared of theta equals 3 divided by 4. So to get to the variable of the angle, I need to take the square root of the left side. Whatever I do to one side, I have to do to the other side to keep it equal. So when I take the square root of something, I know I have a positive or a negative of that. So this is going to be the square root of 3, and the square root of 4 is 2. So I'm just using, if I wanted x squared equals the square root of 3/4, and I took the square root of both sides, I get x equals the square root of 3 divided by 2. Okay, so this is, since I am positive and negative, this means I want cosine in all 4 quadrants, because it's positive in 2 quadrants and negative in 2 quadrants. So from my unit circle, the angle that cosine is the x-coordinate. So where cosine is the square root of 3 over 2, my reference angle is 30 degrees. So these are all 30 degrees right here. So I need to name all the angles in positive rotation. So the first angle is going to be 30 degrees. The next angle is 150 degrees. The next angle is 210 degrees. And my last angle is going to be 330 degrees. Okay. Next equation, cosine squared minus 3 cosine of theta minus 4 equals 0. So I'm solving this similar to x squared minus 3x minus 4 equals 0. So this is where a equals 1. So I want the factors of 4. So the factors of 4 are 1 times 4 and 2 times 2. So my signs are different. So when I subtract them, they total -3. So I know these are my 2 factors, and the higher number is negative and the lower number is positive. So I'm going to factor this as the cosine of theta minus 4 and the cosine of theta plus 1 equals 0. So I know I set each factor equal to 0. So cosine of theta minus 4 equals 0. And cosine of theta plus 1 equals 0. So now I'm solving. Oops. So I get the cosine of theta equals 4. And the cosine of theta equals -1. So on my unit circle, my unit circle looks like this, right? Where this is 1, 0. So this is talking about cosine, which is x, is 4, which is going to be somewhere out here. So this does not exist, so I say undefined. And then where is cosine? The x value, -1. So this is at -1, 0. So that's at theta equals 180 degrees. So theta equals 180 degrees, oops, is my only answer. Right, this one I'm going to solve in radians. So I need to be aware of what the answers are expected to be in, because it says from 0 to 2 pi. So right now I have sine of theta plus 1 equals cosine of theta. So I want this in terms of one trig term, and right now I have two different trig terms. So I am going to square both sides. Whatever I do to one side, if I do it to the other side, I kept it equal. So this is going to be the sine of theta plus 1 times the sine of theta plus 1 equals cosine squared theta. So when I do a double distribute and multiply this out, I get sine squared of theta plus sine of theta plus sine of theta plus 1 equals cosine squared theta. I'm going to combine like terms. So I get sine squared theta plus 2 sine of theta plus 1 equals, and I know cosine squared I can substitute with a Pythagorean identity as 1 minus sine squared of theta. So now I want to move excuse me. So now I want to add sine squared of theta to both sides. So this is 2 sine squared of theta plus 2 sine of theta. And then I'm going to subtract 1 on both sides. So now I total 0. So this equals 0. I'm going to factor out the greatest common factor, which is 2 sine of theta. And I have sine of theta plus 1 left. And that equals 0. Okay, what's going on? Right. Equals, oops, plus 1 equals 0. So now I set each factor equal to 0. So this is 2 sine of theta equals 0. And sine of theta plus 1 equals 0. I divide both sides by 2, so I get sine of theta equals 0. So y is 0. So I'm measuring, so y is 0 here at 1, 0, or over here at -1, 0. So here's where y is 0. So y is 0 at 0 or pi. So this is at 0 and pi. And sine of theta plus 1, so I'm going to subtract 1 from both sides. So sine of theta is -1. So y is -1 here. So this is 0, -1. So this is at 3 pi over 2. So when I give my answers, I'm doing it from 0 to 2 pi. So this is 0 and 2 pi. So when I list my answers, I do them from least to greatest. So this will be from 0, pi, 3 pi over 2, and coming back to the first one again. So that's 2 pi. Okay. So this is just reviewing everything from my unit circle that I know. I can also solve problems with my calculator. So finding the intersection of a point on the graph. Express your answers in both degrees and radians. Round 3 decimal places. Okay, so let's do this both in degrees and in radians. I have my settings here so you can see what I'm setting it up as. I would use, so let's start out with, for the equations, I'm going to put the left side into y1 and the right side into y2. Okay, so when I put secant is 1 over cosine. So this is 1 over cosine. So when I'm putting it in, and then you can see these are my settings that I set up. And I want to be able to see this. So I'm going to mark this as point A, B, C, and D. A, B, C, and D. Okay, so we're rounding 4 decimal places, so I'm looking for the intersecond. So I'm doing second traced intersect for those specific points. And I get x is approximate, or this is equal to 45 degrees. B is x is approximately 123.690. So I guess we're rounding 3 decimal places, not 4. C is x equals 225 degrees. And D is x equals approximately 303.690 degrees. When I change my settings to radians, this is x is approximately 0.785, which is pi over 4. B is at x equals 2.159. C is x is equal to 3.927, which is 5 pi over 4. And D is at x equals approximately 5.300.